Hi, I'm Celia Hurst, your BEYA Stars and Stripes Career Day Student Ambassador. Good afternoon and welcome to Career Day. As we prepare to join the workforce, we want to thank STEM City USA for creating this platform where we can learn about careers we never imagined. More importantly, we are introduced to successful engineers and entrepreneurs in STEM fields who graciously share their journey. Take notes. One day, it will be one of us sitting in their seat, sharing our successful careers with students. Today, you will meet Mr. Jose Gomez. He is the CEO of Fluid Power AI. Vice Admiral Walter Davis, USN retired, will give you a brief overview. Mute your mics and get ready to learn. Over to you, Vice Admiral Davis.
Start again. You're ready.
Good morning. I understand my volume wasn't on. So this is kind of a special day for us. This is the last one we'll do before school starts. So we kind of wanted to demonstrate to you today all the things we've been talking about. First of all, you're going to hear from Jose today, Mr. Gomez, who I really admire. He comes from a background similar to ours. The family didn't have a lot of money to send him to school, but he's managed to take advantage of everything. So you're going to hear from someone who I think you can really relate to. Second of all, his lesson is much like many of yours. He is about a year ago, 2 years ago, when I asked him about, I wanted to give him some interns. He said, no, not only will I take your interns, but I'll show them how to be an intern. And he really did that. He went through a really special intern program when he went to school, and he's a really give back person. But even more than that, I think today what you'll see is what is really the advantage of a STEM education, which allows you to go anywhere and do anything. You can you go to STEM education, you can be a preacher, probably one of the better ones today, because that's what we need, someone that understands both a spiritual world and a science world. That's the hardest thing we have to explain to people today, isn't it? So you get that part of it. And he is very good. You're going to see something very visual today that shows you what he did. So you'll understand what he does when he comes to work every day, what this is really all about. And then better than that, you'll get to see this process of seeing problems, being able to envision a solution to that problem, and being able to determine if you can take that problem that you see and take it into something that will make money for you. So with that, I'll turn it back to you. And thank you.
And so Moria.
Hi, I'm Moria Bowman, and I am a ambassador for BEYA STEM Career Day. And today we have Mr. Jose Gomez, and he is an engineer in charge of a company called Fluid AI in California. Now, without further ado, here is Mr. Gomez.
Good morning, Moria. How are you?
I'm good. How are you?
I'm doing fantastic. It's great to see you. It was great to meet you and speak with your dad yesterday. So thank you for taking the time to do this. It's great to join you guys. As the Admiral said, this is something I enjoy very much because I was blessed enough to grow up and have people that took the time to share their experience with me. And it helped me figure out what I wanted to do and gave me a very clear target on what I wanted to hit. And I believe that helped, really get me there efficiently. And, I attribute a lot of the success to those men and women who took time to do that. And so I feel my responsibility to be here. I enjoy being here. It's great to meet all of you. For all of you that are going to be watching on the stream later, this is a great program, and I commend all of you for being part of it. So thank you.
I have some questions for you. And my first question is, how would you define engineering?
Sure. So this is a great question, specifically because I think engineering is oftenly misdefined, and it causes a lot of us young people when we're getting there to sway away from it because we truly don't understand what it is. So, Moria, have you ever played video games?
Yes.
Okay, so you know in a video game, you've got different characters, and some characters, have, better speed, and some characters have, some characters are stronger, some are smarter, right? And so if an engineer was one of those type of characters, he wouldn't be the strongest or fastest, that's for sure. He wouldn't even be the wisest or the smartest per se. Maybe we'll leave that to the lawyers, right? But the engineer will be the most curious, the guy with the most questions, the guy that's good at asking questions. And so I believe that engineering is the art of asking good questions that will lead you to solve very complex problems. Okay, so I believe engineering is the art or the talent of looking at a problem, asking good questions in order to be able to define that problem and be able to tackle it.
Thank you. My next question is, why did you become an engineer?
Why did I become an engineer? So curiosity killed the cat, right? So I'm a very curious person. I'm not your typical engineer profile, if you will. English was my second language, so I did very poorly in grade school, all the way up through high school, actually. And I was very good at logic, so I understood, the physical world, and I was a very curious guy. I like to work on machines. I like to work on my car. I like to change the oil and help my dad with the engine early on. And my dad was, a type of mechanic, if you will, and an engineer as well. And so I was really exposed to that. So I wanted to become an engineer because I wanted to learn how things worked. And I struggled in school early on because I really was terrible at reading and comprehension. But engineering in physics was about, asking a question and then checking it out and seeing what it, whether it was right or wrong. And so that's why I pursued it. I liked machines and I was a curious guy.
Thank you. Where did you study and what kind of engineer are you?
So I had a bachelor's in mechanical engineering from the University of California, Berkeley. So UC Berkeley, you might know it, or Cal. And I did mechanical engineering and some economics as well there, but my focus was in the mechanics part. And I studied what they call mechatronics, which is when you take the electrical world and you kind of put it together with the mechanical world, right, in order to make systems that are electric and mechanical. And so a lot of like drones, a lot of robots, embedded systems, some of the stuff I'll show you today, which we work on, is all mechatronics. So that's mechanical and electrical together.
Thank you for answering. What did you hate about engineering while you were in school?
What did I hate about engineering while I was in school? So the best part about engineering is that it's going to teach you how to ask very good questions. The part I very much disliked while I was in school early on was that you had to figure it out. I mean, if the whole thing was about asking questions, then you had to come up with the question. And so when you study engineering, they're teaching you how to process a problem. And so there is very little direction. You're not going to get a list of paper with the instructions and go read this and answer this, right? It's going to be a high level problem, and you're going to have to go find the answer yourself. And to someone like me who was very impatient early on, and maybe still is, I struggled with that. I wanted to be told, well, what's the answer? I can do the problem. I'll do the work if I know what to do. But the whole point was trying to figure out, well, what do you have to do? And so I found that stressful. I would say I hated it early on. I found myself a little lost the first 2 years, right? It's like, am I doing the right problem? Am I, is this right? And so it wasn't until about my third year of engineering school, when you start to take a lot of those, engineering courses, that I kind of got a hang of it. Like, oh, nobody knows what's going on, right? It's not just me. We're all trying to figure it out. And so I got my group of engineering friends, right? I created my little niche group, and we went together and we learned to ask questions together. And we knew that nobody knew the answer, and we're all going to figure it out. And then engineering became very beautiful. But those first 2 years, it was scary. It was, a little frustrating. And yeah, I didn't like that very much, but I grew to really appreciate it.
That's very cool. What problem are you looking to solve? And how did your engineering education enable you to execute your vision?
Sure. So I'm going to go ahead and share my screen here. I'm going to show you a few slides. Just really quick before I do this, as Moria mentioned, I am the CEO of Fluid Power AI. My co-founders and I founded this company about 2 years ago. It's when I met the Admiral at the incubator. And I've been an engineer for a while in the industry. I grew up around hydraulic systems. Those are, big cylinders and motors. They move trash trucks. You'll see something here in a second. And I went to work with my dad after school, just selling pumps, motors, and, I became a mechanic, if you will, a technician, and I was designing hydraulic systems. Then I went to go work for United Technologies Aerospace Systems, making things for airplanes. And then I went to go work for Cymer, to go work on ultraviolet lasers that could, make the chips that are on computers. And so I kind of went away from that to start this company. And I want to show you a little bit about, kind of why we did that, what the problem was. But I really want to focus on how much of my engineering training really enabled this, right? And so let me go ahead and share my screen here. And we'll do it like this. You're going to see yourself there in a second. All right, can you see that now?
Yes.
Perfect. So hydraulic systems power the world, right? You may have never known or heard of hydraulics before, but today you're going to realize, like, you see them every day of your life, right? So they really move everything that needs a lot of power with limited space, right? So if you need to pick up trash, then you put them on trash trucks. If you need to, pour cement, you put it on a cement mixer. If you need a big, construction equipment, well, hydraulics power that too. In fact, our military, right, is in large powered by hydraulic systems. The ship the Admiral was on, right, was powered by hydraulics. And so they're really everywhere. And the problem is that every hydraulic system out there is going to wear. That's what it's designed to do, right? When you look at like your brakes in your car, every time you hit the brake, you're rubbing them off, right? And eventually you got to buy new brakes. Well, hydraulics are very similar to that, okay? And they're very cheap to implement, they're cheap to make. And so the equipment operators, or the equipment manufacturers, the guys who make the tanks and the boats and the trash trucks, they love them because they're cheap. But the guys who have to operate, the guy who has to buy a trash truck, or the US military who has to buy that tank, don't like hydraulics because they constantly have to fix them. And the problem is that fixing these hydraulics is very complex, right? There's a lot of different parts in the system. There's oil everywhere. It starts to leak, right? And so it's very difficult to do. And that takes a lot of time. It costs a lot of money. And so 2 years ago, we set out to say, well, what if every hydraulic system was smart, right? What if I could look at any hydraulic system, no matter what type of application it was in, if it was a tank, if it was an airplane, if it was a ship, or even a trash truck. What if I could make a magic little box, if you will, that would be plug and play, just like, your Google Nest thermostat, or, your Apple Airphones, that the customer could truly take this out of the box, plug it in, and his system would be intelligent. His system would have artificial intelligence and could talk to his phone. Imagine if the guy who bought a trash truck could get text messages and have an application on his phone, and the trash truck told him exactly what was wrong, right? The trash truck told him exactly what he needed to buy and what he needed to fix. And so we came up with this idea that we could truly provide plug and play intelligence for any hydraulic system. And it would give value to everyone in that company. And so that's what we set out to do. Let me stop my share screen here for a second. Let me actually here really quick introduce you to some of the team, right? So I have the privilege of working with my dad. He is my chief hydraulic scientist, lifetime business partner, one of my best friends. I also get to work with another one of my best friends, Francis Toglia. So he's an engineer. He's a mechanical engineer, right? And when he was in college, he also focused on mechatronics and really understands these systems in the way that I do. And together, we're able to ask some very hard questions, simplify them, and we can solve some really neat things. So let me show you some stuff here. Let me know when you can see my video again. All right, so here I've got this magic little box, if you will. This is what we call system heartbeat. So this is for the big machines out there. This guy goes in line to the hydraulics, and it could see everything, right? It could know when a part of the system was breaking, and it could know how well the system's doing. This is a different version for our smaller ones that all uses the same intelligent technology inside. But what I want you to see here is that this is mechanical, okay? It's a machine, it's material, right? There's spinning parts in there. And so the mechanical engineering training, right, really helps you understand this. We need to understand fluid dynamics, right? How does oil behave when it's moving through a pipe at very high pressure, right? We need to understand how the temperature affects these issues, right? How much shaking is this thing gonna take when I put it on a trash truck, right? And so how much shaking is it gonna take when it's on an airplane, right? And so understanding, how do we have to design this? How big does this material have to be? How thick should it be, right? Asking questions like, how much does this have to cost, right? Can I make that for $10,000? Do I have to make it for $300, right? And so that now starts to ask questions like, well, what material should I make it out of? Which one's cheaper? Which one's easier to work with, right? There's a lot of things that come into play. I now want to show you kind of the brains, right? So this is a custom circuit board. So this is made by us here. You'll see that we've got kind of 3 different setups. These are all done by us. I'll show you some of the actual design tools that we use here in a second as we take a tour through the shop. But every single pin, every single wire was designed by us, right? We had to pick this connector. You have to understand the signal voltages and, where is this going to be used? Is it going to be used in a factory where you've got, alternating current, or is it going to be used in a mobile application like a truck where you have 12 volts, right? Like your car does. And so all of those decisions have to be made at this level. And this is where the electrical engineering training comes into play. Okay, this is where we start to learn about, well, what voltage levels and how much current draw and how does power, calculated and emitted on these circuits. And so all of this together becomes an electro mechanical system, right? A mechatronic system. These boards here have cellular LTE capability. So just like your cell phone, right? The same chip that your cell phone has, we've got on here. And we can do Wi-Fi, we can stream data, and we can connect directly to the cloud or to any mobile device, right? So our boards can make a phone call. Imagine the day where every trash truck out there can call its owner and say, I've got a problem. Can you fix me? I've already ordered the parts for you, right? That's when we start to extract a lot of efficiencies and really, take the next level, which a lot of you guys are going to be in charge of, right? You guys are going to be in charge of getting us to that new future. And connectivity and mechanical electrical systems are the way we get there. So engineering is important. This is the system. I want to share my screen one more time really quick, and then I'll kick it back to you for some additional questions. This is a visual of the portal. So, what I just showed you goes on a truck itself, right? A physical truck. And now we need to extract the data. Now we need to, analyze any of the analysis that got done at the edge. Now needs to get sent back to us. And so, our cellular device can call home, if you will, and load its data into our cloud-based portal, where now our customers can access the information, right? The insight. And so I'll give you a little bit of a visual here. So, I am very privileged. Could you get that door, Admiral, so that the sirens aren't so loud for them? Thank you. So when we started this, and do I have time, by the way? I'm going to take two additional minutes here. When we started this, we had to decide on what our portal was going to look like. What is that experience going to be for the customer? And so one of the things that many founding teams are forced to do is you're forced to go use whatever's available, whatever is best. And so, in fact, if you go look at a lot of these IoT portals, they all kind of look the same, right? They all have got a menu bar and a user, and you've got all these items. And so we didn't want that. And we were blessed enough to understand the technology and have the skills to build it ourselves. And so we decided that because we are in charge, we get to build a video game experience. We get to build a true portal where our users can come in and we can gamify, we can give them a nice visual experience of what's going on. So this is, our beta launch right here. So you can see, we can show them their trucks and we can show them their location on their map. And we're able to do things like, allow them to filter out and understand, hey, where are my bad trucks, right? Which trucks do I need to go fix? Which pump is inefficient? We're actually also able to allow them to drill down and to see any of the alerts, right? Hey, what is this truck hurting? And then we're able to go in and actually show them, right? Hey, here's all of your information. This is where your truck has been. This is where you had the faults. This is where you missed your pickup. We can show them the trend of their pump efficiency, and we leverage our technology to predict the future for them, right? So why would you have to wait until your truck breaks before you go buy the part that you need to fix, right? The perfect world would say, this is going to break in a month from now. The part gets in, the part is scheduled, the truck drives up into the bay and it gets serviced, right? That is how we reach, the next 10 years of what our world is going to look like with inflation rising, right? We're going to need to extract efficiency. We're going to need to become more productive, right, as a society, and that will largely be on your shoulders, right? And so engineering really allowed us to step back and to ask the question and say, hey, why are hydraulics so hard to maintain? How come the technology hasn't changed for 70 years? Could we make that better? Could the customer have a positive experience? And could we rethink the way technology works and apply the latest and the greatest tech today, right, to make that possible? And an engineering career has been something that enables that. And I think with that, I'll kick it back to you, Moria, and maybe we'll open up for some questions as well. I'll be happy to answer any.
Thank you. Can you show us what you do every day as both the lead design architect and as CEO?
Sure. So I'm going to, I might drop my camera off for a sec. Let me switch my camera and my mic over to the integrated camera here. And then I'm going to take you through a little
Admiral, everybody. Admiral, say hi. We're trying a new sci-fi CAD, so we actually get a little bit of, let me see if I can turn this camera around. All right, I'm gonna hold it like this. Can you guys see that?
Yes. That's a
All right.
really neat office.
All right, more importantly, we have Nerf guns that we get to play with. So, do well so that you're in charge and then you can get guns yourself, okay? So here we go. First thing is I'm going to show you our war room right now, okay? And I call it a war room because we've got a new gen design that's coming out. And so we're actually in the process of testing and validating that design so that we can push it out for production, okay? And so when you do that, we created a little war room. This is an area where, everybody knows that we're here all day, all night, and no one's allowed to touch or erase anything. But we've got all of our notes. We print out our schematics, right? So these are our electrical schematics right here. And we start to redline them, right? And we're putting them all on the wall here. So these are the 3 boards that you just saw there. That's one of the boards. And those are 2 of the other boards right there. And as we start to go through the design, you'll see the design right here. We're actually plugging in these boards, right? We're using oscilloscopes and we're getting on there and we're actually going and checking the little voltages and making sure that every little wire in that little circuitry is wired up properly. And then we run our embedded code on there and we test it for any bugs, right? We stress the system. We bring people that don't know anything about our system and we ask them to try it. We ask them to turn it on so that we could see what is somebody going to do with this if they don't know how it works, and does our system protect itself? Is it capable of that application? And so I'll come over here. As you start to develop these systems, the R&D is easy. They call it 80-20 rule, right? You get to that last 20% where you've got to turn it into a product, and it gets tough to push it through the line. So to do that, you have to start to build, manufacturing processes and little mini test tools, and I'll show you a few of them here. But you can build setups like this where we can go in and program in Flash and get things ready for production, and also R&D development as well. This is a little station where they're going through each and every one of these boards right here, and they're testing all of the inputs and all of the outputs to make sure that everything works properly. This is our main office there. So that is my co-founder and COO. That's my office right there. I just show you because this is where we live, okay? I show you that because that is partly home in there. There are many little fold-out beds where we get to sleep at night and get some rest while our code is compiling or our designs are being tested. I'm gonna come in to our production shop here, and I'll kind of do a backwards walk here. So again, whiteboards everywhere, and this is my VP of engineering is right there. He oversees all of our engineering. He has a mechanical engineering degree from the University of MIT. He also has a master's degree from there as well. So as you can see, a lot of engineers work here. In fact, I don't think anybody who works here isn't an engineer. This is a kind of test and solder station. So here we go in and we are testing boards or getting them ready for fabrication. We actually produce all of this stuff in-house, guys, in terms of the final assembly and putting our product together. And we work with some houses near, build houses here to produce all of these boards. Here's a Gen 1 here. You can see the 3 cellular radios on the top there. You've got cellular Wi-Fi or cellular LTE. Wi-Fi is in the middle, and this is a GPS chip that allows us to track the trucks. And so here is a little bit of the, we'll go here first, manufacturing floor. So this is a test setup for pressure testing our units. Let me see if I can set the computer down here. I'm sorry if I'm making you guys dizzy, by the way. That should work there. Okay, so this is what a unit looks like before it's fully assembled. You can see in here, it's got a little turbine that spins, and we see how fast that's spinning because it makes a little electrical signal on those 2 pins right there. And we also can test the pressure inside this vessel. And we have the temperature as well. And so this little sensor cluster here allows us to get pressure, temperature, and flow into our brains, if you will. But when you do that, these systems are at 3,000 PSI. So you have to make sure that all of your seals are good and your O-rings are well. So we pressurize here. So we take this system up to 5,000 PSI and we hold it there. And we wait for it to leak down and make sure that it's got no leaks on it. And at that point, we can go ahead and assemble the top piece to it. Let me take you over here. This is what the assembly process looks like right here for the top. We start off and we put those Gen 1 boards here on the top of this unit. And then this whole cab will eventually sit on top of that last design you guys just saw. I want to point out stuff like this here. So, instructions for how to put this thing together, right? So that you can hire anybody, even one of you guys could come in, could read these instructions, and could you guys build it, right? A setup like this that says, this is the only tools that you will use for this process, right? This is, a shadow board like this so that every component, goes on the spot, if you will. And that allows you to create a process that can now become a product, right? And it's difficult, right? And there's a lot of engineering involved, right? And once again, a lot of asking good questions to solve some problems. Take you here. Hopefully you can see that. So once those units are finally built up, something like this, right? Then someone's got to take them and do a final assembly on them and a final calibration and test. And so it gets fully built up into here, and they drop them in here, and then they are able to connect these ends right here and run flow to it and verify that all of the sensor clusters and the auxiliary inputs are properly going into the neural networks and into the embedded device, and that we're transferring up the proper insight. All TV back there is not for Netflix. We actually display the data results on there. Big TV, I agree, maybe a little overkill. But once again, you get to be in charge if you do well, right? If you follow the instructions. So you can get TV as big as you need. Let's go back into here, and I'll let you guys ask some additional questions if you've got them.
Thank you, Mr. Gomez. Your office looks really cool. I would really love to have it one day. Now over to General Richardson with questions and answers.
So hi there, everyone. I apologize for coming in a little bit late. And so some of the thoughts that I initially have, and if other participants will, please put your questions in the chat room, and we'll get them to Mr. Gomez as they come in. But Mr. Gomez, as a field grade officer, I had one of my responsibilities as an executive officer of a signal unit was I oversaw maintenance. And of course, we had operators who knew almost nothing. And then we also had mechanics and things of that sort. I can see where a product like this, if it were on my vehicles and my signal equipment, my communications equipment, how it would have just made my life a whole lot easier. But that was 30 years ago. Tell me though, so my question though is, does this product have to be built in as a vehicle or a unit is being produced, or can it be integrated at a later date?
Ma'am, thank you for the question. That is a perfect question and perfect setup, actually. And when I dreamed this up, ma'am, that was part of the problem statement, is to say there are trillions of dollars of equipment out there that are still expected to operate. I worked for United Technologies Aerospace Systems, and our biggest moneymaker was military repairs. We would repair fans that were designed 30, 40 years ago, right? And we would continue to use the same components and keep those supply chains alive. And there was no improvement. And so this product is actually designed and built to be adapted to existing systems. And my focus and my go-to-market strategy is not to the new OEMs, ma'am. I'm gonna let them have to implement my system because you're already using them on all of your existing systems, right? And so they have no incentive to give you that solution, right? It costs them too much money and they do not know enough or have the available technology, and they're too slow. And so we've designed something that allows us to make everything out there right now intelligent. So, you know, to your point, I would be happy to talk to whoever's in your position right now, right? And let them know that their life can be a lot happier with implementing this type of technology. And I do believe the military is making a commitment to that problem statement.
Oh, well, that is fantastic. Yeah, I think I'm sure that Admiral Davis and others have probably told you, but I think maybe the right place to start, especially in the Army, is at we call it Tank and Automotive Command. I think it's in Detroit or somewhere around the Detroit area, and whoever's in charge out there needs to understand what you have so that they can get that to to the folks way down the line, because we would spend days on end and buy parts because people are guessing about what's wrong with the vehicle or with the equipment. And your product, I think, would be much more accurate and would save the military a lot of money. So thank you for that answer. And I'm glad you've come up with something like this. There's a question here from Matt Bowman. And Matt wants to know, how can college students become an intern or start working solve on problems like this while in college?
Absolutely. So first and foremost, I'm always looking for interns. So you'll have my number. Somebody will be able to provide my contact information, and happy to always, kind of provide that because somebody did that for me. I was an intern at Ford Motor Company, and I was an intern at Berkeley Bionics, and I got a lot of, real world experience. So it's my responsibility to provide that. For us, it's contacting us, right? But think about this. If you're in college, there are maybe a few prestigious internships out there, but then there are a lot of other internships out there that maybe aren't even available yet until you go ask, right? And so the idea is, I want everybody to imagine that you aren't owed anything and you don't deserve anything, but you will do anything to get that, right? And so one of the benefits that I had is I went out and I looked for unpaid internships. I said, who can't pay me? Because I know that they have the most work to do and don't have enough people to do it, right? And so I would say, I'll take an unpaid internship. And look, for me, it was my opportunity to try it. If I didn't like it, I didn't like it, right? They weren't paying me anything. I could walk away. I also had the benefit of having a full-time scholarship from, the Bill and Melinda Gates Foundation. So if you're in high school, start applying for scholarships so that you could go out and work for free, right? The VTech program, the military has some programs that will pay if you are a veteran, right? And you served early on in school, then you're able to come back and get paid while you're in school and shortly after you leave as well. And so, as far as how could you do this, just get up, right? Get up and get out there and go pick up a phone and understand what an internship is for, right? Take the benefit of the internship, right? You're not there to do a job. You're not there to make money. Come on, guys. You're not trying to get rich off your internship, right? And so if you go in there, you do the job, you ask the questions, you will eventually, kind of be able to make your own path, right? So that's my advice there, man.
Oh, well, thank you so much. I think that was very good advice. And so Simone and Shay Gary want to know if there are any girl engineers, and I know that there are, so the answer to that is yes. But let me ask you, do you have any women working at your place?
Great question, ma'am. First of all, there are many women engineers, and I want to kind of clarify that. Look, a lot of the stuff you see here, is machines and oil, but engineering is everything. You could be a lawyer and be an engineer. The best, kind of process executives are engineers. Remember, engineering is just about asking questions, right? And so, you know, some of the best engineers that I know are women. There's a company at Evo Nexus, also incubating. It's called the Good Face Project. I believe they're changing their name, but it is all women. And one of the girls that works there is literally a rocket scientist. She was working in Ukraine somewhere, building, you know, rockets for their space program. And she does neural networks, and they use artificial intelligence to advise women on what healthy and good beauty products are, what is good for your, and they make a perfect match. And think about that idea that there's a group of women that are some of the best engineers, and they're out there saying, hey, every woman deserves, you know, healthy, good products, and we're going to do that for them, right? And so no women working for me at the moment. Unfortunately, not a lot of women sign up to come work at trash trucks and oil. It's not great for your guys' nails. But I actually am currently courting a few of my engineer friends that I work with who are both girls, who would be great to help run the business side of things and the marketing side. And so they currently work for Apple and LinkedIn, I believe. So definitely a lot of girls out there. If any girls want an internship in hydraulics, got plenty to do here as well. So give me a call.
Okay, so you heard that, Simone and Shay. There may be a possible internship there for you with Mr. Gomez. Say, does it matter what college that you go to?
Oh, fantastic question. Thank you for that. Ma'am, I very much disliked Berkeley my first 3 years. It was scary. I'm a Southern California boy, and Northern California was a different world to me. And one of the things that I figured out was that the school didn't matter. Guys, I knew people that went to Berkeley and Stanford that are terrible engineers right now. They took zero advantage of what they were doing there. They didn't understand. They were trying to get the work done so that they could get the degree and go out and make some money, right? They weren't trying to get trained so that they could go to do a mission and execute that mission, right? It was a different type. And so then I know my co-founder here, he went to the University of Washington, still a great engineering program. And then he moved down here to San Diego and finished up at SDSU. He is one of the best engineers I've ever met. His ability to ask questions, his ability to, you know, withstand pain and stay there at 4 a.m. as you keep trying it. He really understands that. And so I would say the only thing that matters is how much you care and how unafraid you are to ask the question. When I was at Berkeley, most of my professors had a terrible accent. I could barely understand everything. They were brilliant men, but terrible professors. They could not teach. And so I learned fluid dynamics and statics from a book. I read a book, right? I had to go there, read a book. I practiced the problems with my friends, and I understood the material, and I went and asked the teacher and the TA. And so, look, if you go to any school and you put in the work and you read those books and you ask the questions, it doesn't matter. You could be working at NASA, Tesla, and hopefully Fluid Power AI.
Okay, all right. Well, I think it is important to understand that that you should be in a profession that you care about, that you enjoy, and it's not just about nickels and dimes and how much you're gonna make. If you don't love what you do, you're probably not going to be very good at it. Or at least that's what I have found through my experience. So
Absolutely.
I'm assuming your dad though was pretty good at engineering and liked what he did. Was he your inspiration? or did you have other mentors?
I was blessed with many, many mentors. My dad was definitely the one that brainwashed me into thinking hydraulics were cool early on. He's working on them a lot, mainly because he wanted the help, I think. So, I went out there. But, I had the blessing of listening to my dad say to me, look, kid, you can do anything you want, but I have zero money to pay for it. So go find the money first because it's out there. And, he was definitely, he and my mom to put that, installment in me, and that really helped out. So, yeah, I think my dad's been great at that and always a great problem solver.
Okay, all right. Well, are there any, you mentioned several types of engineering, mechanical, electrical, and I'm sure there are others. Is there one that you think is the best to major in?
Absolutely. I've got a combo answer, right? But for, like you said, ma'am, number one, it's what you like. Okay, look, if I say the best thing is computer programmer right now and you hate programming, like you're not going to enjoy it, right? And so there are many types of engineering, right? Industrial, process, bio. I personally encourage young men and women to go the electromechanical, right? The mechanical engineering or the electrical and computer science route, mainly because that's where our world is going, right? And so very specifically, even when I do, the reason I encourage mechanical is because mechanical gives you the widest exposure to all of the little worlds, right? You understand some programming, you understand some of the bio, some of the chemical, some of the nuclear, right? You understand the optics part of it. And so that really gives you a good kind of feel overall for them. And if you don't know exactly what you want, mechanical engineering is a great one because it gives you a lot of exposures. It is very tough because you have to see so many different, right, kind of worlds. But it's a great one. The other one that I would recommend a lot right now is computer science, right? And programming and really understanding how computers communicate, how they work and how they talk. Because like if you're in high school, the next 15 years of your life is going to be all about, that digital world transformation.
All right. So you sparked an interest in interns, I think, at your location with Simone and Shay with a previous response you made. And they want to know, at what age do you take interns? And then Lavette added on to that, what are the prerequisites necessary to intern at your company?
Yeah, sure. So let me tell you about the interns we have right now, okay? And tell you about what they do. So I've got about 4 interns from the VTech program. They all come through the Admiral. And they are currently in their second, third, and fourth, years at school right now. And so they understand enough to be dangerous, but I want to make very clear that I take my internship programs seriously, and the objective isn't for me to get work done cheap. It's for me to give you some exposure, right? So I've got a few kind of high school internship programs where it's more about like, hey, let's talk about an embedded system. And then I ship you a little, embedded controller, and I say, hey, here, turn these lights on and run this thing, and just give you a simple problem that then we can use that on one of our test systems, right? But really get you more of the exposure. So I consider anything from seniors and juniors, because juniors, your most important year in high school, is getting that in. So those two I have an internship type that I like to do, and working with the Admiral to get kind of streamlined. But if you are an engineer in college, any year will do. I interned for Ford Motor Company as a freshman at Berkeley. So if you've taken math, right, and you understand algebra and calculus decently enough, then you should be good to go.
Well, Mr. Gomez, thank you so much. You've been so insightful and informative, and just a delight to listen to. So we have come to almost the last couple of minutes of our time, and we're going to move on and have, I think I'm going to pass this to Matt, or maybe even to Admiral Davis to try to close this out. Admiral Davis?
Well, General Richardson, I'm going to take a point of order and just make some real brief comments. Mr. Gomez, that was phenomenal. General Richardson, ma'am, is always phenomenal. I think the walkthrough, I know for me, seeing the lab, seeing the bench, seeing where you work was just so powerful. For the parents and the teachers and the principals who are online who'll be viewing this was our last session before the school starts. So these children, our studio audience, will be broadcast across the nation. And so we've had 7 people so far, 7 leaders in our series, BEYA Career Day. We've had an astronaut, we've had fighter pilots, we've had the man who put the GPS in cell phones, Mr. Steve Poizner. We've had entrepreneurs, we've had cybersecurity experts, men and women. But I want to hear from all of you, from the parents and the children, on what comes next. Who wants to have the CEO of TikTok be on here with us? Who wants to have one of the world's top motivational speakers? So stay tuned throughout this year. We're going to get to that, and we're going to bring that message to you. And again, Jose, that was absolutely phenomenal. I just can't thank you enough, sir. And with that, go ahead, Jose.
Appreciate the time. And, like I said, anything we could do to help our young men and women out and, get that exposure and learn the experiences, please feel free to contact me through the Admiral or directly, and I'd be more than happy to help.
Yeah, when you talk about problem solving, seeing the size of the space, and that is something that almost anyone can do with the right equipment and who has a great problem to solve. So that was so inspiring.
Thank you.
Admiral Davis, sir, over to you to close this out.
Good. Now this, do we go to another part, or is it closing out for the day?
Closing out. Closing out.
Yes, sir. We will close out for today.
Okay, good. Well, great. I want to just add one little thing about the interns. Now we've got to hold your hand up, by the way, all your students and be an intern. Great. So one of the things I've really enjoyed here, I told you about 2 years ago when I asked Jose if I could bring him an intern, and he kind of really took over. And I really enjoyed seeing the interns come through his place, because Jose's the kind of person that will lead you, will give you the incentives, but he'll also push you. He'll realize after he's worked with you a while, he'll understand what your talents are. And sometimes, how we are as kids, especially when we're really doing well, we're making all A's and right. Next thing is another A, right? But Jose is the kind of person who will, get you to that next level. So I'll come over here one day and he'll to get a brief from him, and he says, "Okay, Admiral, intern Gooch is going to give you the brief today." And that really builds you get to do that part. It really builds your confidence. You're scared to death the first time, but he knows you're going to stumble a little bit initially. But those kinds of experiences, I think, are what you need. And hopefully those of you out there who are and listen to his story will be the kind of person who just pushes himself in there, get in the door, get to be sticky. That means taking the trash out, take the trash out, so they want you around. And then push yourself to get to where you're getting the most out of this. So this has been
Terrific, Jose. Thank you for doing this. I think this is a really fitting in. We're going to send you a questionnaire out, by the way, all of you, so you can tell us a little bit about where you'd like to go from here, which things you'd like to see. I would take a little exception to that. I think I'm not necessarily looking to see the guy that did TikTok. I want to hear the guy. I want to hear from him when they got the. And if he does come, I want to hear when he got his hands dirty. And that's the part I think it gives us confidence that we can do this and shows us. I think today you get a little bit of this out, how to do that stuff, how to be willing to go down the street and walk in that door and say, I'd like to see what you're doing here. So that's our next steps. We'll send a little questionnaire out to you and hopefully you can get a little insight on what you get out of this and what you would like to see for the future. And then Sean Richardson, I want to thank you again for being such a big part of this. And Celia and Maria and Maria, for your part of this. You'll help us take this to the next level also. So with that, I'll turn it back over to you, Pat, and then we'll see you during the school year. We hope to bring this program now to lots of folk. I'm going to be talking to principals. If you have ideas about what I should be saying to them, send those words to me so I can convince them to have access to their students. So,
all right. Well, great, Admiral Davis, sir. Thank you. And we will work on that list of speakers for the year. And for all the children and parents, once again, have a great Saturday. And we'll see you next month, the second Saturday of September. And study hard and enjoy the first part of the school year. Signing out for BEYA Stars and